Hello, good morning, good afternoon, good evening, wherever you might be. My name is Sean, and I'm delighted you are joining us for today's ESPC Community Webinar. Today, I am joined by Henning, who will cover exploring graph semantics in Fabric real-time intelligence. We love hearing what you guys have to say, so remember to join in on the conversation about today's webinar and more on X. Our handle is @ESBC_community, and our hashtag is #ESBC24. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which is updated daily with the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointeurope.com, and clicking Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar. Don't make me think the challenges with Microsoft Copilot and how to solve them with Nick Burrell, MVP. This webinar will take place Wednesday, 9th of October, 2024 at 11 a.m. to 12 p.m. CEST. For more information on this webinar, please check out www.sharepointeurope.com/register for webinars. Time is ticking. Don't miss the first ever European Microsoft Fabric Community Conference, #FabConEurope. Join us in Stockholm from September 24-27 for exciting sessions led by Microsoft Fabric experts. It's your chance to dive into cutting-edge insights. Limited tickets available. Book now and secure your spot at www.sharepointeurope.com/European Microsoft Fabric Community Conference tickets. Early bird sale alert for #ESPC24. Dive deep into the latest in governance, Azure, SharePoint, Copilot, Microsoft Teams, Viva Topics, API, AI, Microsoft Entra, Power Automate, Microsoft Purview, and more. Don't miss out. Register your interest today at www.sharepointeurope.com/pricing. We're excited to announce the call for speakers for EPPC 25 is officially open. This incredible event will take place in Vienna from June 16 to 19, 2025. And we are looking for Power Platform experts to share their insights with a community of over 2,000 plus enthusiasts. If you're knowledgeable in Power BI, Copilot, Power Automate, Copilot Studio, Power Pages, or any other Power Platform tools, this is a fantastic opportunity to present and inspire others. Submit your sessions today at www.sessionize.com/European Power Platform Conference EPPC 1402. After this webinar, we'll have a questions and answer session. Type any questions you might have into the questions box. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it is available. And now, I'm going to pass you over to today's webinar. Henning. Hello, Henning. Thanks for joining us today.
Hi. I hope you are able to hear me. Okay, seems to be working.
Yeah, I can hear you perfectly.
Nice. So let me share my screen and we can get started.
Yeah, I can see that.
So, yep. Okay, so welcome to the session. Session about graph semantics, fabric real-time intelligence. I'm incredibly thankful for being invited. So thank you so much. And by the way, like you were talking about FabCon. I'm going to be there next week as well. So feel free to drop by, ping me. I'm happy to talk with you about all kinds of fabric, time series, and whatnot. Quick introduction for myself. My name is Henning Rauch. I'm a principal product manager at Microsoft, and I'm working in a product group who's building Cousteau. I'm going to talk about what does that actually mean, what does Cousteau mean, how does it relate to fabric real-time intelligence in a second. I've joined Microsoft, I believe, in end of the 2016, and fell in love with this technology of Cousteau around real-time data ingestion, time series analytics. And at one point, I decided to join the product group who's building that product. And I'm incredibly thankful for being a part of that. And as part of my job, I'm responsible for security, and that means responsible for stuff like network security, so virtual network injection, private endpoints, also our Kusto role-based access model. And besides that, I have a couple of topics that I cover in our engine, in our database engine, and that is all things geospatial. So we introduced a vast amount of geospatial functions for our customers to use. And my latest quote-to-quote investment, which is really, really close to my heart, is adding Kusto graph semantics directly in the Kusto engine. So, and that's what we are going to talk about today. Okay, so let me go and talk a little bit about the family, okay? Because I'm going to use like several names for the technology throughout the webinar, and I don't want to confuse you too much. So when we look at the stack of like Microsoft products, I'm working at the bottom of the stack, of the tech stack, which is Kusto. Kusto, at the end of the day, it's a database. It's a distributed database which can scale to crazy numbers. At the end of the day, it's a distributed relational database built on top of a column store. We're probably the best kept secret at Microsoft, and that's where I'm dealing with graphs, security, network, geospatial. On top of that, over the time, we released multiple products, and that's also part of my job. So I'm part of the Fabric Real-Time Intelligence product group, where we are releasing our RTI or Event House product. I'm also part of Azure Data Explorer. That's our offering on Azure, our PaaS service called Azure Data Explorer. And last but not least, we also released a container of our engine so customers can explore Kusto capabilities in disconnected CI/CD environments, for example. So Kusto is at the bottom of the stack. We built multiple products on top of that. One of them is Fabric RTI, the focus of today, but there's also Azure Data Explorer and Kustainer. Now, other teams in Microsoft build products on top of that, on top of those services. One of them that you I think should or must know if you're working anywhere on Azure is Azure Monitor. So whenever you're monitoring an application or some infrastructure, you're probably are well aware of log analytics or application insights. All of that is part of Azure Monitor. And at some point, when you dive into the details of your telemetry of logs, you will find a weird query language, which is called KQL, and that's the Kusto query language. So whenever you see KQL, you know that under the hood is actually Kusto. Other like very, very important products are everything that Microsoft is doing with regards to security. So all security related data eventually lands in a Kusto cluster somewhere. And we build products on top of that, like Sentinel or Microsoft Defender, to help defend Microsoft and our customers. If you are a gamer like me, you probably know like a lot of studios that Microsoft is working with. Some of them are using an underlying technology called PlayFab. And PlayFab is also built on top of Kusto or Azure Data Explorer in that case. And there are tons of those. There are tons of those services which Microsoft built on top of this technology. Just to give you an idea of the size that we're dealing with, I want to show this quick diagram. It's not 100% up to date, but it doesn't matter. It's still like very, very impressive. Those numbers are probably like 3-4 months old. Just keep in mind, we're talking about a relational database, a distributed relational database, and we're ingesting roughly 220, I believe nowadays it's close to 250 petabyte in the relational database every day, which is just crazy, crazy numbers. And from Microsoft point of view, roughly, I would say 99.999% of all log and telemetry data is ingested into Kusto. So definitely key to Microsoft digital transformation journey. There are billions of queries running there every day, and if you sum up all of the data that is stored in this technology, it's roughly 20 to 23 exabyte as of today, and that's a compressed number. I think uncompressed, you can easily say times 7, so 140 maybe to 200 exabyte of data that we're storing in this relational database. It's running on a substantial amount of cores in Microsoft, I think meanwhile roughly 5 million cores, and they are depending on how you're calculating, something like 500 to 550,000 KQL developers out there. So if you have never heard about this technology, you should definitely invest some time and see if it fits your needs. So now we know a bit about the technology stack, which is Kusto, the different products that were built on top of that. Now let's go a little bit deeper into Fabric and Fabric real-time intelligence. So Microsoft actually did a great move. I think it was last year when we announced that. So we created a SaaS offering of all of our analytics tools, which is based on a couple of very interesting paradigms. One of them is definitely that all data will be stored on one lake, and we wanted to make it very easy for customers to store the data in one place and then use it by multiple engines. So we built on top of one lake, which is unified data foundation, a couple of verticals, starting from data integration, data engineering, data warehouse, data science, Power BI for business intelligence and observability. And Fabric real-time intelligence is a comprehensive service offering by Microsoft that allows to get insights on data as it happens. Okay, so it's not that you have to store the data first and then after some time you get insights from it. The idea of Fabric real-time intelligence is to be able to work on data as it happens. So it handles and intakes large volumes of data, as you have seen with the numbers in Kusto. The data is stored securely and analyzed in real time or near real time to provide immediate insights. And it comes with it comes with dashboards out of the box and other visual tools that helps you to understand trends, anomalies, patterns. And last but not least, of course, we also we integrate with AI tools to automate responses, provide the co-pilot experience to make it easier to work with the data. So far, so good. So everything that I'm going to talk about today is happening in that little box in Fabric real-time intelligence. And later on, I'm also going to show a quick demo. But now, how does it all work together with graphs? And what is it actually that term graph, that construct graph, is kind of a mathematical construct. And over the last, I would say, 20 years, or maybe even more than that, companies created databases that were specialized on querying graphs or processing graphs. One of those companies is definitely something like Neo4j, memgraph, tigergraph. So those are the big players when it comes to graph databases. There's also the world of graph processing, and here you might want to search for words like Pregel, for example. But what is it that a graph is comprised of? So at the end of the day, a graph is comprised of nodes and edges. And edges are connecting nodes. So to stay with this example here, there are a couple of nodes like Alex, Alice, Bob, and Dave. Alex is reporting to Dave. Alice is also reporting to Dave, and Bob is reporting to Alice. Those graph elements, as both can be called together, nodes and edges, can have properties. Properties like in this example, the type reports to, or the node Dave has a property name Dave, and there are a couple of other things that you can do with it, such as labels, and but it's already too much detail. What we're dealing here at the end of the day is a property graph. It can be used for an incredible amount of scenarios. for hierarchical data, network relationships. Social networks is probably the easiest one to think of. Recommendation systems, connected assets, knowledge graphs, and in general, like many-to-many relations. We started this journey already some time ago in Cousteau, and I'm going to show you now actually why we had to add some sort of graph semantics directly into our engine. So what you see here is a drawing of a scenario, a classic scenario of friend of a friend. So in every graph or graph database, I would say documentation or video or whatnot, people talk about that scenario because it's very, very easy to visualize. So if there's a person who knows another person who knows another person. So the first one on the left-hand side, the first bubble is a node, and we are searching for a friend of a friend. Now at the bottom you see a KQL statement. So KQL, as said before, is the Cousteau query language. If you have never heard about it, I have some links at the end of the deck, and you can do your research later. It's a very modern language, and what you see here is a couple of tabular expression, one for users and one for node, one for the nodes relation, which are edges, and then we are actually creating a join. You know, join is a construct in a relational algebra where you're using a relation table and you try to get from one side of the relation to the other side of the relation. So you start by something like an organization of Cousteau, then you do a join to get to other users, and then you do a couple of other joins to get to the other users. At the end of the day, if you look at graphs and graph databases, the construct of graph could also be explained with relational algebra, and there are a couple of systems which are actually doing that more or less well. But what you see immediately, if you look at and the way that this join construct or this KQL statement is written, it gets very, very, very hard to digest at some point. So just imagine if the construct would be a little bit more complex, or you would need to do some additional filtering because you're not interested in all of the friends. It can become incredibly hard to write at some point, and also for people who would like to understand what is actually going on, it also becomes very hard to understand. So it's hard to write and hard to understand at some point. And here, the constructs that graph databases build over time are actually incredibly helpful. You will see later on what we did. Besides the ability of reading and writing complex joins, at some point it doesn't even work. And that's what you see here. So, for example, the classic Cousteau joins, they're not able to do recursive traversals. So you start maybe at a Cousteau person on the left-hand side, then you have a person in the middle, and then if you have the friend of the friend. But what if you also want to have the friend of the friend of the friend? So you have a relation, you have a query, a path pattern that includes variable length edges. So you're interested in, for example, the length of 2 hops or length of 3 hops, and that's something that you can't express in a single join statement, which is a big problem. So the only way to express it using joins in KQL is expressing it with fixed length patterns, which is limiting definitely the usage of this technology for graph related scenarios. Now, without further ado, I'm going to show you what we did with KQL and Cousteau and graph semantics. So KQL, just to repeat, KQL is the language of Cousteau. Cousteau is available in real-time intelligence in Fabric. That's why it matters here. So what we did for this to work is we started, as you see here, again with 2 tabular expressions. We start with the edges, which is also something that's called the adjacency list. So A is connected to B, or one user is connected to another user. And we are creating a graph using a make graph statement. And this make graph statement is creating a graph representation during query time. So it takes the adjacency list for nodes and creates a graph during query time, and then allows subsequent operators to work on that graph. The operator that most of our customers are using, and the first one that we actually built, is graph match, which is comprised of 3 parts. The first one is the pattern, so the graph pattern. The second one is the constraint, starting with the where. And the third one is you need to translate back to a tabular expression in order for other operators to work on the result that those graph operators produce. Let's go through it one by one. The graph, the path pattern here, named user knows friend of a friend, consists of 3 parts. We start with a user, which is a node. Then there's a directed edge, which name is knows. That edge has a variable length path, has a variable length. It has at least 1, which means you need to traverse at least to the next node. Or it can go up to 3. So it can be the friend of the friend, the friend of the friend of the friend, or the friend of the friend of the friend of the friend. This is a classic pattern which is used by modern graph databases, and probably the closest that comes to that is OpenCipher. What we try to do is come up with a syntax which is deeply integrated into existing KQL and Cousteau, and allows to reuse existing concepts from the graph code. That's why we decided to go for that mix. The second important thing is the constraints, which starts here with where. If you know Cousteau, then where is just a classic filter. So you can filter for the organization named Cousteau, and then you say, okay, but you know, the user ID of the friend shouldn't be the same as the initial user, because you don't want to find yourself in the friend of the friends. And last but not least, you want to continue in KQL, so you're projecting from those paths the Cousteau person and the friend of the friend. So this example, if you compare it to the initial join that I've shown to you, is way more easy to digest. So you can read it. It's easy to also put on a whiteboard, and it's also easy to explain and easy to write. So what was actually the reason for adding this to Cousteau directly? We have a lot of customers, as you have seen previously, who store, for example, like petabytes and petabytes and exabytes of data in this relational database. So, and some of those customers ask themselves, hey, we would like to have now a way of exploring the graph of our data. Do we need to have another graph database on the side, or what can we do in order to work with the data as a graph? So sometimes they have implicit graph data structures, sometimes explicit data structures. So if you already have a lot of data in Cousteau, it makes sense to add a portion of graph semantics directly to the engine instead of pulling out all the data into a different database. So one reason is definitely gravity. And if you are able to add, let's say, the 80% of the use cases directly into the engine, and you don't need to have a second database on the side, it definitely also decreases the cost of ownership at the end of the day, because you don't need to manage a second database or third database. It can all live in one database. The third one is a true selling point for this technology. We look at graphs in the same way as we look at other data in Cousteau. So we look at graphs as a series of events. So a node is being added, an edge is being created between 2 nodes. You can add a property to an edge, you can add a property to a node. It's a series of events where all of them have a timestamp. And our technology allows you to say, I would like to look at the graph at a specific point in time. So I can look at the last known state of the graph, or I can also say, go back 3 days and have a look at the graph in the way that it looked 3 days ago. That's very important for a couple of scenarios that I'm going to cover in the real world use cases section. And last but not least, KQL. So KQL is the Cousteau query language, and we did all of these integrations for customers to have a good developer experience. Our previous integration always covered like sending a string, just a regular string, to some other endpoint, which is something like a graph database. And it's hard to get the IntelliSense for that. It's hard to find mistakes easily that you made. And we didn't want to continue with that. So we said, okay, let's have a deep integration into our own query language. Let's extend the syntax. Let's invest and create graph semantics. So for people who like KQL, this will be very, very easy to work with. Of course, all of that doesn't happen like in one go because it's a large project. So the first phase that we now released as GA in, I believe, like May 2024, works on tabular expression. So you take a tabular expression like A is connected to B, and you create a graph during query time, and then you continue. So here you have a lot of like flexibility to create whatever you like from a tabular expression. It can be data sitting on one lake. It can be data sitting in a native table. It can be data that is sitting somewhere on a SQL or on a Cosmos DB. So you get a lot of flexibility, but it's a query time construct. So the query time construct gets lost after the query. So every query gives you a penalty or additional latency for creating the graph during query time. For graphs, I would say up to the size of a couple of millions, that's not really a problem. So the latency that you add is negligible. But for larger ones, this is definitely increasing the latency. So what we're going to do, and what I'm going to talk probably in the near future, again, is we're going to add persistent graph entities, which will reduce the latency and optimize the overall query performance. Now with that, wherever you see Kusto, wherever you see KQL, you're able to use graph semantics. So it doesn't matter if you're using ADX or Fabric Real-Time Intelligence or Azure Monitor or even Synapse or free clusters. You know, you can have a free cluster where you don't need to like pay anything for it, and you get I think like 2 cores and 100 gig of data, and you can have like graph semantics there because we embedded it in at the bottom of the stack in the engine. You can use it now everywhere, which is pretty incredible. So let me share a quick demo of how we can use graph semantics in Fabric. So it's what you see here is Fabric, and I've now opened an artifact, a KQL query set, which is connected to a database, to an event house. And what this scenario is showing here is something that's called offensive security, also Bloodhound. And what I tried to show here is how like other queries, how other databases are using graph query language in order to express the problem that they're trying to solve, and how we can do that directly in Kusto or in Event House in Fabric Real-Time Intelligence. So what you see here is I'm creating a graph object with a let statement, so it's just an expression. And something very cool happens here. I'm using an external table or a shortcut to OneLake. So the data is not actually running in the engine of Kusto. It's external and it's sitting on OneLake. So all your data estate in Fabric is supposed to be on OneLake, and you can query it using any engine that you like. And in this example, that engine is Event House. So this one is querying this adjacency list, the cybersecurity edges. And then it's creating a graph object during query time. It says, okay, I want to map source to destination, and it's connecting it with, it's enriching the nodes with information about the nodes sitting in a different folder on OneLake. And then it's doing it's implementing like 2 graph match operators, one for the user access and one for the group access. So what it's doing here is says, okay, I'm interested in users that can RDP into a computer. See, it's very easy to read. It's very easy to digest. You don't need to think about complicated joins. And the second one here in line number 19 is a user that is a member of a group that can RDP into a computer. So again, like very easy to understand. And when you run it, what happens is the event house is being created. So that's why the initial query takes a little bit longer. So we're creating a complete new database here. Then it's the engine is reaching out to the underlying storage, querying the data from that storage, creating the graph, and then processing the graph match operator. So all of that is happening in right now 7 seconds, which is very long, but you have to take into consideration that the entire event house was created. The graph was read from a storage like OneLake, and all of that happens instantaneously here. Now, this is a very interesting statement. It's a little bit more complex, so I'm not going too deep into it, but it's working on a scenario which is very interesting for IoT and industrial IoT. In IoT systems, let's think about a production line of a big manufacturer. All of them are measuring the data of sensors, so they collect sensor data. And think about this scenario as being a pump in a production line connected to a different asset or an asset, and that pump has a pressure sensor. So you would like ingest all of that pressure sensor data into something like real-time intelligence or event house, and then you would like to find anomalies. So there are out-of-the-box capabilities in event house to detect anomalies. And that's what you see here in this part. So we're getting all of this sensor data. We are creating a time series. From this time series, we are filling up values. Then we are finding anomalies, and then we are tagging assets that have anomalies. All of that is happening in this single statement. Now we are building the graph using this part. So we are interested in something that happened on a specific day. So we do something that's called the graph time travel. So we are creating the graph at exactly the point in time that is interesting for us. So we get the adjacency list or the assets and how they were connected and at a specific point in time. We get the nodes that were part of these assets at a specific point in time. And then we are creating a graph over here. Once we created a graph, we are using this statement to find out, hey, what is actually the impacted production line by those anomalies. So here we're finding all anomalies in the first part. And now we're doing something like a blast radius analysis. So to go back to the initial example, I start with a pump that has a pressure sensor, which has anomalies. And now you want to find out what happens if that pump explodes. Okay, so what is the blast radius of that asset having a malfunction? And in order to do that with other systems, you would need to have like a time series database, a graph database, some glue code which is connecting all of that together. And here you have everything in a single place. You get IntelliSense of KQL, which is very convenient. Yeah. So once you defined the pattern, you just say, okay, I'm interested in asset that have an anomaly. And at the end of the day, I would like to say that I'm interested in the lines or production line. So I'm filtering down here, and then I'm projecting back the asset and the factory. And last but not least, I can calculate the impact using a summarize statement. So what you see here, it's a combination of time series database, including time series capabilities, graph capabilities, and just classic, I would say like Custo BI. So you're doing a group by a couple of dimensions and you're executing it. Again, this will take some time because I probably waited too long until it ran. And what you see here is that everything is super fast and you can use time series and graph in one statement. If you're interested in visualization, then you probably know like that actually most of our experiences are built for data engineers, but still, you know, we have a good some good visualizations in some of our tools. So this is a visualization of a social network, and the visualization is done in something that's called Custo Explorer. It's a free tool. It's creating a 3D graph of users that have repositories. And what is also very important for a couple of like security scenarios, cybersecurity scenarios, is to understand like how a certain graph was developing over time. So all of that, what you've seen before, can also be visualized in a tool that is called Gusto Explorer, and we're also going to bring it to the web. But it's just a small example of how graph visualization could look like. Okay, so that was the quick demo that I wanted to present to you. Let me go back to the slides and talk about real-world use cases. Real-world use cases, we've seen a lot of customers dealing with cybersecurity scenarios. Cybersecurity scenarios because a lot of the security, like the world security data, is actually landing in this database. So there are customers who are building customers and internal products who are building on top of Gusto or Event House or Azure Data Explorer. And in this scenario, it's about exposure management. So a cybersecurity scenario that explains how exposure management plays a pivotal role in fortifying organizations' defense against potential threats. You have the URL there, you can read all of the details. And what this article is talking about is the introduction of graph semantics and the effects on security teams, that it enables efficient investigations of a security posture across organizational assets. This talk is really going very, very deep into existing Microsoft security products and how they're using KQL and how you can be using, how you can use KQL as a user. So if you're interested in cybersecurity scenarios, I definitely recommend to have a look at this talk, or at this post. The next one is manufacturing ontology. So if I look at, I would say the vast majority of users who are using Gusto graph semantics in Event House or in Fabric in general, it's definitely security, but the second biggest vertical of users is everything around IoT, industrial IoT, manufacturing. And this is a Learn article about a reference architecture of how to create a manufacturing ontology. It's not only covering the manufacturing ontology part, it's also covering how you should be, like a recommendation of how to get data into the cloud. It's also talking about a specific format, which is in OPC UA, specific standardization in this scenario, and how you can ingest that data into something like Fabric real-time intelligence. It's comparing architecture between Fabric and past resources. So if some customers are interested in past resources, they can go the Azure route, or if you're interested in a SaaS experience, you can use the same technology in our SaaS world, but just way easier and super easy to connect all of these different technologies. So that's something that I can definitely recommend you if you're in like collecting data from production plants, standardized data models and ontologies in the manufacturing space. Last but not least, I decided to create a small, I would say, sample of graph usage for digital twins. So digital twins are trying to create a digital representation of physical assets and beyond. And I created an example which is simply connecting the history of a digital twin with Gusto or an Event House. And this blog post or this, I think it's a GitHub repository, is talking about how to integrate with a digital twin, how to get all of the history data from a digital twin. For example, an asset was created or a digital twin was created, it's connected to other digital twins. So all of that is history information. And this is, it's explaining end to end how to create a digital twin using the digital twin definition language, how to connect a service like Azure Digital Twins to an Event House, and also how to run queries on top of that using graph technology. And this one is explicitly also talking about how to do graph time travel and get the information of a digital twin at a specific point in time in the past. Okay, So a couple of information that is very interesting for people who want to follow up on all of that. So I can definitely recommend to go to powerbi.com and get your access to Fabric and try out everything that you want to try out that you've just seen in my presentation. If you're interested in specific graph-related stuff for Cousteau, I have a couple of links here where I'm explaining the basic concepts of graphs and how does it apply to our technology. So I'm talking about an overview, and then I talk about all of the operators that we have for graph. If you want to follow on social, we are posting information about graph stuff on LinkedIn or X, and we usually use the hashtag called Cousteau Graph. So just follow us over there. And then you can also rescue Professor Smoke from crypto, who's a bad guy, and save the KDA. So what's KDA? KDA is the Cousteau Detective Agency. At some point, I mean, you have seen there's a lot of information here, and you can read documentation all day long. We decided at some point in our team to take a different approach when it comes to training. So we decided to create a game, and that game we called the Cousteau Detective Agency. It's now already we released the second season last year, and I'm not sure, maybe there's something coming up this year. I guess you will know in a couple of weeks. And what you're doing there, you are a detective and you get cases. And the cases, they get like more and more complex. You start with simple stuff and it gets at some point like really advanced, but you know, it's a fun ride. You get Cradley badges, you can sit together with others and think about how to solve specific scenarios. So, and what we found out is that this works way better when it comes to bringing somebody up to speed with our technology. So if you're into Cousteau or Event House or Fabric Real-Time Intelligence, go and check out the Cousteau Detective Agency, and I put a link over here. Visualization of graphs is a very interesting field, and it's a field of its own. We recently released a blog post in our tech community, so that's the link over there. And if you have feedback on our technology, I'm more than happy to take it. So that feedback brings it to a form, and you can raise all of the feedback of stuff that you like, that you don't like, what you see as graph operators to come up in the future, and it's a direct integration to us in the product group. Now, having said that, I would say let's switch to questions if you have some.
Yeah, so thank you, Henning, for a great presentation and demo. So now we'll get into the questions and answers part. Should you wish to ask a question, please feel free to type it in the questions box now. So our first question today is, what do you see as the future direction of graph technology in real-time intelligence, and how can organizations prepare for it?
So the future is definitely bright when it comes to graph and real-time intelligence. I can't talk about everything that's going to come, but you can expect like big announcements in the future. So I definitely see that we are not only focusing on this graph pattern analysis. So I see the future when it comes to graph analytics. And the main thing that we would like to follow is that you don't need to do like big ETLs to work on graph data. We would like to directly connect data sitting on one leg and work with graphs. So the future is extending the capabilities of Cousteau or in Event House, and also provide analytical capabilities.
Perfect. So just next question there is, what recent advancements in graph technology have you found the most impactful, particularly in context of real-time intelligence?
I have to say, what we are doing, it's very impactful. I just realized that after we did our first customer interactions, the first customer, because something like this is not really there on the market at the scale that we are operating. So the capability of being able to ingest data at like petabytes per day into a table, and then being able to create a graph on top of that table in real time, and do things like graph time travel. That's something that wasn't there. So I'm in the graph space since a couple of years. It's very close to my heart, and there are like so many great industry players. I named a few in the beginning, but I definitely see that that what we are doing is adding an additional angle to it that I've not seen before. So the combination of real-time intelligence, of technology like Custos or distributed column store, plus graph capabilities is, in my opinion, the biggest advancement of graph technology in the last couple of since ever. And we also see that like on the traction that we are seeing in a service. So it's a moment, it's growing like crazy. The graph usage is going up, and we didn't even talk that much about it. And we don't even have something like a persistent graph at the moment. It's all in memory. So from customer feedback, from others, and from my understanding is, when it comes to the graph space and being able to do graph time travel tightly integrated with the column store, I definitely see a big value in what we are creating, and also one of the largest advancements in graph technology.
Perfect. So just the next question there is, how do you ensure data privacy and security when using graph semantics in Fabric real-time intelligence, especially when dealing with sensitive information?
It's an excellent question. So, and that's where, the graph semantics in Cousteau are just piggybacking on existing technology in Cousteau. So Cousteau, first of all, is, or Event House is a highly secured environment. Okay, so the only way to authenticate on it is using an Entra identity. So there's no such thing as, I don't know, basic auth. We're not doing that. And then when it comes to security, you can secure your environment by turning off the public access, and you're only able to access it using something that's called a private endpoint. So you have your private connection from your own virtual network to the infrastructure. And we have our role-based access, which is based on a database level, where you can say some people have viewers and others have user roles and all of that. But the question that I'm getting a lot in the last couple of days and weeks is, how do I implement something like node level security or property-based security, or like edge-based security? There are a couple of names for it. I'm not sure if there's a good explanation for that at the moment, but we have a feature in Cousteau that's called row level security. And in that row level security, it can be highly dynamic. So you can say, I'm only allowed to see rows if I have a specific Azure Active Directory identity or Entra identity, or I'm only allowed to see certain rows if I created an Entra token from a location somewhere in Germany or somewhere in the US. So, and that mechanism of row level security can be applied to those edge lists, to those adjacency lists. So you can say, I'm only allowed to see a specific edge between nodes if I'm Henning Rauch, so with my identity here at Microsoft.com, and if I'm dialing in, or if I created a token from the country Germany. So the entire graph that we are creating contains only information that is relevant for me. And all other information is not even in the graph. So there's no point in saying, okay, I need to create a persistent graph. This is what traditional graph databases are doing. And then I need to secure each and every node and only allow to traversing that node or go to that node if I am a specific person or some specific properties are fulfilled. Here, even the creation of the graph is limiting the graph to exactly the scope that I'm allowed to see. So I hope that answered the question.
Yeah, so I think that's all the questions we have. So on behalf of the ESPC community, we'd like to extend a big thank you to you again, Henning, for taking the time out today to carry out this webinar. Really appreciate it.
Yep.
So,
also, thank you from my side. And so I didn't want to interrupt you, but if you'd like to reach out to me, a couple of ways of reaching out to me.
Amazing. Thank you, Henning. So that's the end of today's webinar. You'll find this webinar and more at sharepointeurope.com/resource center. Thanks again for you all for joining us today, and I hope you join us again soon. Take care.
Take care. Bye.